What if the one thing that has guided travelers for centuries suddenly went crazy? What if the invisible shield protecting our planet from deadly solar radiation began to fail? This isn't science fiction. It's a geological reality happening right now, deep beneath our feet, and it could be leading to a silent extinction. Imagine our planet as a giant, spinning magnet. Deep within, a churning ocean of molten iron, the outer core generates a powerful magnetic field. This field stretches out into space, acting like a cosmic shield, deflecting harmful charged particles from the sun. It's also what makes our compasses point north. But this protective field isn't static. It's a dynamic, ever-changing force, and right now, it's doing something that has scientists watching very, very closely. Let's travel back in time. Not just a few years, but hundreds of thousands, even millions of years. How do we know what the Earth's magnetic field was doing back then? The answer is locked in stone. When volcanoes erupt, the molten rock or lava contains tiny magnetic minerals. As this lava cools, these minerals act like microscopic compass needles, aligning themselves with the Earth's magnetic field at that very moment. Once the rock solidifies, that magnetic signature is frozen in time. By studying ancient lava flows all over the world, geologists have discovered something astounding. The Earth's magnetic field has completely flipped or reversed hundreds of times throughout its history. North became south, and south became north. The most recent full reversal, known as the Brunhes-Matuyama reversal, happened about 780,000 years ago. So we know it's a natural cycle. The big question is, are we on the brink of another one? Now, let's fast forward to today. For the past century, scientists have been tracking the movement of the North Magnetic Pole, the point on the Earth's surface where the magnetic field lines point vertically downwards. For a long time, it drifted slowly. But in recent decades, its speed has dramatically increased. It's left its historical home in the Canadian Arctic and is now racing towards Siberia at a speed of over 50 kilometers per year. This isn't just a scientific curiosity. It has real-world consequences. Our entire modern world relies on precise navigation. Aviation, shipping, even the GPS in your phone, all need to account for the location of the magnetic poles. The World Magnetic Model, which is the basis for all this navigation, has to be updated more frequently than ever before, just to keep up with this rapid shift. It's like trying to navigate a ship while your map is constantly being redrawn. But there's another, more concerning symptom of this magnetic wobble. The field itself is getting weaker. Globally, the magnetic field has lost about 9% of its strength over the last 200 years. And this weakening isn't uniform. There's a particularly large and growing weak spot stretching from Africa to South America, known as the South Atlantic Anomaly. In this area, the field is so weak that satellites passing through it are more vulnerable to damaging high-energy particles. They've experienced computer glitches and data corruption, forcing operators to shut down non-essential components when passing through the region. This anomaly is a clear sign that the geodynamo in the Earth's core is becoming more chaotic. So, what does this all mean for life on Earth? This is where we get to the idea of a silent extinction. Many species rely on the magnetic field for navigation. Sea turtles, birds, bees, and whales all have an internal magnetic sense, a biological compass that guides them on their incredible long-distance migrations. If the magnetic field becomes unstable, chaotic, or significantly weaker, it could disorient these animals, disrupting their breeding and feeding patterns. It could be a devastating blow to already fragile ecosystems, happening silently, out of our sight. And what about us? During a reversal, the magnetic field doesn't just disappear, but it becomes much weaker and more complex, possibly with multiple north and south poles scattered across the globe. This weakened shield would allow more cosmic and solar radiation to reach the Earth's surface. While it wouldn't be an instantaneous apocalypse, increased radiation levels could pose long-term risks to human health and would put a huge strain on our power grids and communication networks. Imagine a world with frequent satellite failures and widespread power outages. So, are we doomed? Not necessarily. The good news is that a full reversal process is incredibly slow, taking thousands of years to complete. There is no evidence in the fossil record to suggest that past reversals caused mass extinctions. Life, it seems, is remarkably resilient and has adapted to these dramatic planetary changes before. But our technologically dependent civilization has never experienced one. The current shifts are a powerful reminder that we live on a dynamic and ever-changing planet. We can't stop the forces churning in the Earth's core, but we can study them. By monitoring the magnetic field, improving our models, and understanding the potential risks, we can prepare. We can design more resilient satellites, reinforce our power grids, and continue to unravel the mysteries of this incredible magnetic shield that makes life on Earth possible. The poles are shifting, the field is weakening, but with scientific vigilance and preparation, humanity can navigate the change. Thank you so much for joining me on this journey to the Earth's core and back. If you found this topic as fascinating as I do, please hit that like button, subscribe for more deep dives into the wonders of our world, and let me know your thoughts in the comments below. See you next time.